Hello and welcome to our session on some grade 10 math. We are going to talk, or let me just first say, we're using IXL to generate some examples for us to help our discussion. Feel free to explore that platform, use your own that you know already, or any book. But you do need to practice these things a little bit more than what we can do in the video time. We're going to talk about polynomials, all introductory things, but that doesn't mean it has to be easy. We're all at different places in our journey. Now, I just want to remind ourselves, let me go dark here. Ooh, that's nice. Of the distributive property. My pen is a little wobbly. It's not me. I'm not nervous. It's just the way it looks. Distributive property for numbers. I can take something simple. Let's say 4 times 9. Of course, we all know what that is. Whoops, if I can write correctly. There we go. I can also view it in a more detailed way. I'll split the 9 up and write this as 4 times, let's say, 6 plus 3. Just to illustrate a property of addition combined with multiplication called the distributive property. And we casually say we're multiplying the 4 into the bracket. We're going to multiply the 4 times 6. I don't need brackets there. I'm just illustrating that this is what I'm doing. And then I'm adding whatever that operation is. Could be subtraction. The 4 times 3. And I want us to just verify with easy numbers that we're getting the same thing. Well, this is 24 plus 12, and I get my 36. However, when we have variables mixed in here, then we don't have the luxury of simplifying the bracket and performing the calculation just with multiplication. The distributive property is very often necessary to help us simplify things. But remember, it is a property of numbers, and variables are just hidden numbers. So let's go. Get rid of that, get rid of that. We are going to look at some simpler ones first. I think it's this one. Yes. Go. Load. There we go. Come on. Slow loading. Wow. So here we have the same situation. 7 times two things that I cannot put together. They are not like terms. The distributive property is how I'm going to simplify this. So I'm going to multiply the 7. I'm going to emphasize that. 7 times negative m squared. You can write the times symbol there. You don't have to. The brackets do the same thing, especially to make it clear what is being multiplied. You can even do that. Minus 7 times 2m. Multiplication symbol in there if you feel like it. So that's an equal like that. Now I'm simplifying this expression, simplifying this term, and I'll write it as negative 7m squared, just so it looks a little bit nicer. If there's a negative, it goes in front, number in front of the variable portion called the coefficient. And here, I can put some of these together and write 14m. Now, of course, if that confuses you, we are building on basic algebraic expressions with variables. So you might have to go back, or maybe this is too easy and you can go forward and look for other videos in our playlists. You'll have to decide for yourself how to do that. That is as far as we can go, because the m squared term and the m term are not like terms and cannot be put together. We're trying to simplify. So I want to write here. It's a little annoying to type in here, but we do want to get verification that we are correct. I want m squared. What did that do? That seemed to not do what I want. Let's get rid of that. No, I want to get rid of that. How do I get rid of that? Oh, no. Oh, no. There we go. The m first, it seems. Then I want to square it. There we go. Now I want to minus 14m. That looks like what we wrote down. Sure. Brilliant. All right, so for this one, we have the variable in front as well. And how I'm going to write this is the whole negative w times the two-term bracket, like so. So now I'm going to use the distributive property to multiply this in, and I'm going to choose to write down exactly what I need to do. As you get more comfortable, you can simplify this on the go, but right now I'm not ready. I'm multiplying this into my first term in the bracket, plus this plus, my pen is acting weird, that's okay. The first negative 2w times negative 2w times the second term. Pen, stop being weird. Now this line is optional as you get more comfortable, but don't rush it. Don't. It's not worth it. Make sure of every step. That's how you're building good habits, and it'll naturally streamline as you go. Here I have a negative 2w times a negative 3w squared. Two negatives make a positive. 2 times 3 is 6. W times w squared gives me w cubed. Here I have a negative 8, which I can write as minus 8w. These are not like terms, so I really cannot put them together because I don't know what w is exactly. I'm just simplifying the expression. So let's write that in 6w cubed minus 8w. And we'll leave it there. Well, actually, no, we will not leave it there. I'm talking nonsense. Let's have a look at this one. I'm going to leave this one for you to practice, and we'll move on to making that first factor a little bit more complicated as well. But see if you can do this one. Let me know in the comments what you think the answer is. We'll have a little commercial time, and we'll be back with slightly more complicated ones.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
All right, here's another example where you see we now have a more complicated first factor. It is its own bracket with two terms, and then I have a second bracket with two terms as well. Now I'm going to expand on why we eventually do what we do using this first example to help us understand where is this coming from. I don't encourage we just use a formula or a shortcut without understanding where it comes from, because then I'm kind of stuck at that level. If I understand what I'm doing here, I can use a shortcut for convenience, and I have the luxury of expanding on this and handling more complicated things without really learning anything new. But I have to put in a little more effort in the beginning to lay that foundation of understanding. Most people don't want to, and then they get stuck and they're shocked at why they can't handle more difficult things. Well, you never really understood it in the first place, so it makes kind of sense. So I'm going to just look at this h plus 3 as one thing for now. And again, I'm not going to do this necessarily every time, though you totally could. It's just a little more writing. But it helps me to understand why the thing looks the way it does at the end. So I'm going to multiply the first blue rectangle using my distributive property. Just copy that blue rectangle times 3h, and then plus, same distributive property, and then times the 3. Same distributive property like so. But now I'm going to go pink here to just highlight. This on its own is another distributive property. Whether I write the 3h in front or at the back, I have to distribute it into the bracket. Now I'll just keep them in the same order as they were originally. So I'll have the h times the 3h. It doesn't matter if it's now distributing it in from the right. It's the same distributive property. Plus the 3 there times the 3h. Let's go maybe blue. We're adding this, adding those. Let's go black for this one because this is another distributive property, distributing the 3 into the bracket. H, that h, times 3. I just use the brackets. I don't like the time symbol that much. Plus 3 times 3. But of course, you can use a time symbol. There's a lot of notation options for how to write this. All right, so now let me just look here for a second. I'm just going to erase this. So I want to, yes, I can simplify this, no problem. But it doesn't quite help me to understand and get something more efficient for later. So let's number these things. This is number 1. This is number 2. This is number 3. And this is number 4. So this term is 1 and 3. The first one from the first bracket, the first one from the second bracket. I'm just using the numbers to reference them easily. So we'll call those ones the first ones that we're multiplying. Then we have the 3, which is the second term here, times the 3h. That is the inside terms. Sort of, they're the closest together. Inside being multiplied together. It's all going to make sense in a second. Then for this h times 3, we have the first one from the first bracket and the last one from the second bracket, the outside ones. Outside. And lastly, we have the 3 from both. Those are the last ones. Now that's just how the distributive property and sequence popped it out. This doesn't make a good acronym, right? FIOL, file. But what we instead use is just swap these two because it's all being added together and it gives you a nice little acronym. If I can write properly, it would look better, of FOIL. So often we say we FOIL it out. However, it's just the distributive property over and over and over. So let's keep that in mind, but for now, we can simplify that very easily because we've already done the work through the distributive property. This FOIL is just a shortcut to help us get it without thinking of the detail every single time. But I can always do that because I understand what I'm doing. So I have a 3h squared from the first one. I have a 9h. I am potentially running out of space, but that's not a problem. From this inside one, I have a 3h from the outside ones, and squeeze it in a 9 from the last ones. I'm just going to put it over here, because these are like terms. I can put them together for a 3h squared plus 12h plus 9. 9 h's there, 3 h's there, 12 h's. Let's put that in. And we are ready to continue to the next one where we'll try the FOIL shortcut a little bit. 3h squared plus 12h plus 9. Let's go. Awesome. Let's try this again. But now I'm just going to write this again over here. So it's a little bit bigger and I can draw some arrows. We have z minus 4 times 3z plus 3. I'll use pink for my arrows. So now it's going to be first. So these two together, which will be, oh, no, do them pink. I don't have a lot of colors. Blue, I guess. Z, 3z. Then we're going to go outside. Outside ones are over there. That is z times 3. Adding those. Then we're going to go inside ones. According to FOIL, will be these two. Swapping colors here. Negative 4 times 3z. I could have gone a minus there, I know. And then lastly, well, the last ones, which will be these two. For a negative 4 and a 3. I'm foiling it out, but it's just the distributive property. Now let's simplify. 3z for the first one. No, z squared. Plus, this one is 3z. This one is now minus 12z. And this one is minus 12. But the middle terms are like terms I can put together. I could have done that on the go. As you get more comfortable, you can choose to do that or not. 3z minus 12z is negative 9z minus 12. And there we go. The FOIL is just a shortcut for what the distributive property is doing a little bit more slowly. So it is handy, but never forget that I'm understanding it first, because this does get more complicated, where foiling is really only for two brackets with two terms in them each. The foiling gets a little bit more messy if I have larger brackets, and then it's really back to the distributive property, which is not a big deal because I understood what I was doing. So understanding first, and things down the line, I guarantee you, are much, much easier. Let me just check if that is copied and typed in correctly. That looks good. And I wouldn't say we're brilliant, but I accept the offer. Now we have one here, but I will leave this to you so the video doesn't get too long. Have a look, see what you get. Let me know in the comments what the answer is, as well as any other questions you might have. And we will meet each other for the next lesson soon. Until then.